So the first question was, would taking average of multiple readings from tapes installed at the leeward direction of the wind improve the pressure readings, or is it recommended to collect at only one location?
No, I think measuring at multiple locations and averaging might make sense. When we've tested big buildings, we almost always measure using 4 separate pressure channels on the 4 sides of the building where the building meets the ground. And often the average of those 4 pressures gives the lowest standard deviation, although it's often true that just the single measurement on the leeward side gives the lowest standard deviation. So I haven't done this, so I'm not sure, but I think it might improve things.
I think it's a recommendation from ASTM, right, to take multiple reading.
For who? From who?
From ASTM, from the US standards, no? It's not recommended in the ISO 9972.
No, I haven't seen any recommendations to measure at multiple locations on the leeward side. I think it is in the 3150 ASTM 3158. There's a suggestion that it might be good to measure on 4 sides of the building and averaging those 4. I like the idea of measuring, especially if you're using software where you can turn channels off and on after you've measured. So you can measure at multiple locations, and then you can look at your data, especially at the zero flow pressures, and you can see which one has the lowest standard deviation, then decide to do your calculations based on that location. Or you can average all of them and see, oh, that has a lower standard deviation. I'll use that for my regression. Now, maybe we're cheating by doing the regression on data from several different places, and we're kind of picking the one that looks the best. But I don't think so. I think that's a good idea.
Okay, here is a comment about the variation of the interior barometric pressure, which you were emphasizing that it was varying more than the external. So it says that the interior barometric pressure varies depending on the wind pressure fluctuation on all faces of the building. That is not the same as the pressure variability at a single outdoor sheltered locations. So it's for the comment. He thinks that it's normal, that it should be different. So
Yeah. I would agree. They're certainly different. If they were exactly the same, if the outdoor barometric pressure at some location were the same as the inside, then the pressure difference that you would measure there would be 0, or that you wouldn't see any pressure fluctuations.
yeah, you would have find a way to exactly reproduce the house in a small in a small box or something. What we need is a location that best represents the wind and stack impact on the envelope pressure. That isn't necessarily the location with the lowest standard deviation. How can we address that? And I think that this goes with the last question, which was, have you tested the impact of the location on the result of the airtightness tests? As I guess you do have a reference value for your house that is quite
What we want to measure is oh, are we on number 3? I'm sorry.
We are number 3, yeah. But I think it goes with, it can also be answered with number 5, because what is the most important is that we have the less impact at the end on the result.
Well, for steady wind and stack effect, I don't think it matters where you measure the pressure. We're concerned here about uncertainties due to the noise, due to the fluctuating pressure. And steady wind, if it exists, I don't think steady wind really exists, but if you look at models with steady wind or stack effect, there aren't pressure fluctuations. So there aren't errors in our zero flow pressure measurement due to the stack effect. I mean, we can measure exactly what the pressure is due to the stack effect at any location, and we subtract it off, and if there are no fluctuations, there's no errors due to the fluctuations. There are, of course, bias errors due to the stack effect, but I think those you should calculate from a calculated total stack effect of the building rather than the measured stack effect at one location, because that doesn't tell you what the stack effect is. If all of the leaks are at the bottom of the building and it's a 100-story building and there's a big temperature difference, and you can measure that there's zero stack effect there, but of course there could be huge uncertainties because of the stack effect in that case that you wouldn't even be measuring because of where you're measuring. So I think for bias errors due to stack effect, I think you really need to calculate what is the total stack effect pressure in the building.
Okay, and I think the fourth question is about the same, so I think we still have a debate on that. Are we sure that the result with the lowest standard deviation are the best? Imagine that we have a standard deviation equal to 0 would be the best location. What we want is to measure is the absolute pressure variation as it is. So I guess
Well,
the idea, yeah.
if the standard deviation is 0, then there are no variations. And it is the best location if what we're trying to do is minimize the errors or uncertainties due to the pressure fluctuations. Now, if we're also interested in, well, what are the pressures due to the wind? What are the pressures due to the stack effect? We're not addressing those in the measurements that I'm suggesting here. I think for stack effect, you have to calculate it. You shouldn't measure it. And well, you should measure it to get some idea where is the neutral pressure zone of the building. You can learn a lot from measuring it, but I don't think you learn much about the uncertainties from measuring the stack effect at one location. And I think the same with the wind. It's probably better to have an estimate of what the wind speed is than it is to try to measure the zero flow pressure due to the wind. I don't really know. I'm not.
Yeah, I am. But well, what is important is to be representative, I think, and that's what.
Yeah. We want it to be reproducible. We want reproducible results.
To
We
find a
wanna,
reproducible results. Yeah, it's
that's what my whole paper is about, or my whole presentation is about, minimizing the effects of the fluctuating pressures.